Welcome to today's webinar, which discusses IP Fabric and its end-to-end path simulation feature. We will be testing the end-to-end path in the main user interface, which will be over traditional switched routing and firewall topology. But more importantly, we will attempt to use the same feature by only using API calls. And for the API testing, we will use the Postman platform, which I find very interesting and useful. So you will be able to see all the audacious details of the API calls and responses that are materializing under the hood of IP Fabric. And now let's quickly follow with the agenda. So in the first part, we will explain very briefly what the path simulation feature in the IP Fabric is. In the second part, which will be more interesting, is the practical end-to-end path simulation within the user interface. We will have a quick look about how to get the information about API documentation. And then in the third part, we will deep dive into the API analysis with the Postman platform. I will quickly explain what do you need to set up your environment and to send a first call, and we will analyze the responses in details. Uh, Before the last part, we will quickly talk about the possible use cases, how you can or where you can find a feature useful in your network automation ecosystem, and at the very end, we will go through a brief Q&A. So stay tuned and let's go for the first part. So now we are in the IP Fabric platform, and at the top left we have a couple of snapshots ready for our path simulation. And this is the topology we are using for the webinar. So as you can see, we have two main hosts slash servers, and between the hosts, so we don't have a very robust network. So one host on the left, the other host is connected to the switch on the right. And this is not a network simulation. This is just a topology in IP Fabric. So at this point, we are not simulating anything. So now let's quickly talk about a path simulation feature. The network path simulation feature in IP Fabric is an essential part of any network troubleshooting for any network engineer. I would say all the time. My rough estimate, which is coming from my 10 years experience in network operations, is that possibly more than 90% of all incoming tickets are related to finding the network path based on the source, based on destination IP, and analyzing it further. And usually the manual, or you can say the command line interface effort invested depends on how well do you know the network. If you know the network well and the network is fairly simple, you can find your path pretty quickly. If the network is very robust, which can be more than 5,000 routers, and you are new to the team, it can be more time consuming. And this is what IP Fabric solves brilliantly. And the significant advantage of using a platform like this is that it offers an intuitive interface, either graphical or the API interface, for quickly and accurately diagnosing the path in a great detail. We can view resulting topology with all its network hops and interfaces, or we can get a really deep dive, which we will do shortly, and view all possible ticket headers on each individual hop of the path. More importantly, the IP Fabric has a unique snapshot feature that allows you to compare the current state of the network with its past state of the network. And this is including the path analysis. And by comparing the two, you can very quickly and easily pinpoint the exact source of the problem and take the necessary steps to solve it. So that is for the quick introduction of the feature, and let me show you more technical details. We will be simulating unicast path lookup from a defined source to a defined destination, but there is much more that the platform offers. You can even get the list of all connected servers within the entire network in a specialized inventory host table, but right now here, what we can do is this. we have the unicast path lookup. We can select the multicast tree lookup as well if we want, defined by concrete group and the receiver. We can simulate a very simple host to the gateway, but we will focus here on the unicast source to destination path. So the only thing we really have to do to find the right path is put in the source and the destination. By the way, you can also put in a destination subnets, which is extremely useful when it comes to simulating a single source to a subnet, which can represent a group of users or servers in IP Fabric, and you can analyze all the security policies on the path for a selected subnet. You can predefine your advanced packet header options. So what we have in here predefined in IP Fabric right now is a ICMP, echo request, and web traffic, which is represented by two destination ports, 80 and 443, but you can play around a lot. You can define your source regions, destination regions. You can even set up expected TTL for the path, and a lot of other options. Now we will keep it simple. We will put in source and destination, and we will be simulating the ports 80 and 443 through our two firewalls. So hopefully the traffic will get through. By the way, IP Fabric is not only simulating within the traditional IP space. We can simulate within the cloud networks, which is AWS or Azure at this point. We can simulate very well within the Cisco ACI environment, VXLAN environment. We can simulate on MPLS, including VPN, vForce, and so on, and the list continues. So now, we have our source, we have our destination, so let's analyze the path further. So I'm going to hit submit. And very quickly, which is in a matter of seconds, we have our results. So as I said before, we can see just a very high level overview of the topology from source to destination, but also, more importantly, we can analyze any hop on the path. So now at this point, when we have the simulation path ready, let's analyze the hops in greater detail, and very quickly, because we want to mainly talk about the API. So we can have a path, we can see how the path is looking in terms of topology, but if we want to get more details, I mean, we can quickly understand that the source is connected to the switch. We understand that 1001 is the VLAN number, so we are taking the frame, switching it over to a layer 3 switch, and then it's going over the IP space again. If we want to see more details, we just simply click with the right and see the details, where we can see, okay, how the packet or the frame is looking like before it enters the device. Here are some operations that are occurring inside of the device, and this is how the packet looks like when it leaves the interface. We can click on next, where leads us to the next device, which is the firewall. And again, we can see a similar thing, like this is the incoming packet, this is how it looks like. These are the operations which are occurring inside a firewall. So we are taking the packet, trying to find the match in the routing table. We find the next hop, then we find the match in the ARP table to define or to figure out where the next hop actually is. And we are also using the security policies lookup to understand if the source can reach its destination based on the specifications we define in our path lookup. So just by clicking on the security policy, it will show us how exactly policy is built on the firewall that in this case permits the packet. So this is all for a high-level overview, and again, there's a lot to talk about but for this webinar we would like to focus on using IP Fabric's API. And now, where to get the details? So when we have the path ready, we can just click on API documentation at the right middle bottom corner. And to simulate the end-to-end path over API, we have three main endpoints. The first endpoint, which is /graphs, will give us all the necessary information to reconstruct the path with the JSON data. The next one is the SVG of the network topology or the path topology, and the other one is PNG. So these are basic documentation, and there's a lot of other important or less important things in the request payload. We can just simply use the top part for the end-to-end path definition to use in our Postman or any tool for prototyping. And these are all the possible options that we can use for pretty much defining how the path will look like and where all the nodes will or will not be placed and all the possible colors and so on. We have more in our documentation. I would recommend read it thoroughly before using. And now let's quickly open our Postman and see how we can use the API to get the same response in the Postman. So now at this point, when we have the simulation path ready, let's analyze the hops in greater detail and very quickly, because we want to mainly talk about the API. So we can have a path, we can see how the path is looking in terms of topology, but if we want to get more details, I mean, we can quickly understand that the source is connected to the switch. We understand that 1001 is the VLAN number, so we are taking the frame, switching it over to layer 3 switch, and then it's going over the IP space again. If we want to see more details, we just simply click with the right and see the details, where we can see, okay, how the packet or the frame is looking like before it enters the device. Here are some operations that are occurring inside of the device, and this is how the packet looks like when it leaves the interface. We can click on next, where leads us to the next device, which is the firewall. And again, we can see a similar thing, like this is the incoming packet, this is how it looks like. These are the operations which are occurring inside a firewall. So we are taking the packet, trying to find the match in the routing table. We find the next hop, then we find the match in the ARP table to define or to figure out where the next hop actually is. And we are also using the security policies lookup to understand if the source can reach its destination based on the specifications we define in our path lookup. So just by clicking on the security policy, it will show us how exactly policy is built on the firewall that in this case permits the packet. So this is all for a high-level overview, and again, there's a lot to talk about but for this webinar we would like to focus on using IP Fabric's API. And now, where to get the details? So when we have the path ready, we can just click on API documentation at the right middle bottom corner, and to simulate the end-to-end path over API, we have three main endpoints. The first endpoint, which is /graphs, will give us all the necessary information to reconstruct the path with the JSON data. The next one is the SVG of the network topology or the path topology, and the other one is PNG. So these are basic documentation, and there's a lot of other important or less important things in the request payload. We can just simply use the top part for the end-to-end path definition to use in our Postman or any tool for prototyping. And these are all the possible options that we can use for pretty much defining how the path will look like and where all the nodes will or will not be placed and all the possible colors and so on. We have more in our documentation. I would recommend read it thoroughly before using. And now let's quickly open our Postman and see how we can use the API to get the same response in the Postman. So now I'm going to be quickly switching over to the Postman, and for me Postman is one of the best prototyping tools for the APIs. It's a leading platform for API development and testing, allowing developers and Python enthusiasts to create, test, and share APIs easily. With Postman, you can design, develop, and test and document APIs faster and easier than ever before. Postman's powerful features include the ability to design APIs from scratch, validate requests, automate tests, and much more. And with the Postman, you can make your API development streamlined and efficient with a full suite of tools and features to help you get your API up and running quickly. So let's dive in and explore the world of the Postman API platform right now. Here, the first thing you need to do is set up the environment. I'm going to quickly show you where you can define your key in IP Fabric for API. So it's simple as that. You will go to the settings and API tokens, and you will generate your token. As for the environment in the Postman, I'm using a very simple environment definition. As you can see, I have the end-to-end path environment, which is the environment for my private server. I have the default URL, which please be very careful with versioning of the API. Starting version 5.0, we started to version APIs with every major version, so that will change with every major. Here you will place your API key, and once we go back to our end-to-end path endpoint, we can use the base URL based on our environment, and the only thing we will do is we do /graph. Now, we need to define our payload. So if we go back to the diagrams and end-to-end path, and we hit the simulation, if we want to get the exact same response, we just ask for the API documentation here, and we can simply copy the payload to the clipboard. We go back and just paste it here. Now, let's see what we get. So we just send the request, and this is our Postman response. So we quickly check what data we can have. So basically, the way it works is that as a response to your request, you will get the full definition that can help you to fully reconstruct the path, including all the information about the results, right? In this case, the result is very simple, and it's at the very end. So we have the passing traffic all. I mean, there are three main options. I think that one of the status is fail, the other one is all, and the third possible state is partly or part. That is especially useful when you are simulating, let's say, /24 subnet, and not all of the IP addresses from the subnet will pass the security policies. Then the result is not fully pass or all, but it's just partial. The other part of the response, if we go to the way to the top, is that you have the nodes and the edges. The nodes is simply the list of all the devices or all the possible hops that are that the path is using. So here we have the defined host by the serial numbers. You have the type switch. This one is L3 switch. This is a firewall, and so on. And then the second most important thing, if you ever decide to try to reconstruct a path, is the edges, because the edges are definitions of the packets or the frames that are either entering or leaving any network or logical device that is participating on the path on the network. So as you can see, with all these details that we have available as a response, you can fully reconstruct the path simulation from the API response. So if we take a quick look back into our topology, so let's see the first or the very first hop. We just click right on the detail, and this should be the first edge in our API response. So we have the Ethernet destination MAC over here, which is ending with CFA7. So if we go back to the Postman, we go for the list or dictionary of the edges, and this is our first part. So we see that the first edge is defined as the host with a device, and there's an exclamation mark, and there is a name of the device with its interface, which should be ET02. When we go back to the topology, we see that it's exactly this particular interface. So the first edge is defined as the host and the first switch. When we go back to the Postman, we have more information about a packet. We have the destination MAC for where to send the destination frame, and the only thing we are really doing here, I think, is just switching, so there's nothing else going on. We have more information about labels and so on, and yeah, target traffic, interface name, subnets is all true. And then this is the second edge, which is defined by XSW02, like a switch 02, ET1, pairing with a device XR03, which is the first router, and ET4, which is the edge right between these two devices, right? If we want to get more details in IP Fabric, we can just click the next, and we're gonna see the same information as in the API response. So now I hope I provided you enough information from under the hood, and let's have a quick look about how we can simulate or how we can get the image. For example, let's talk about a use case where some of IP Fabric users are using the path simulation feature to integrate that and create basically a chatbot wherein you put in your source destination. So you do like command, which will be like /IP Fabric, then end-to-end path feature, and show me the path from the source to the destination. You define the IPs and the ports, and the chatbot will respond to you with an image. Now, instead of the data, if you want to switch to the image, instead of getting the JSON response to IP Fabric, you just change the endpoint, but you can keep everything else as it is. Let's have a quick look back at the API documentation. So in case I want to get an image, I click on API documentation, and now it depends what type of image I want. If it's going to be either SVG, which I think it's pretty much preferred, or PNG. We can try both. So the idea is just to put in a SVG behind the graphs, and we should get our picture. Perfect. So being in dark mode, it's not beautiful, but we can see our SVG that can be used in a chatbot integration pretty quickly. So now I would like to share with you a couple of use cases that this API data from the path simulation can be useful for. So let me bring it up. So the use cases, where to use the data that IP Fabric can simulate and how to implement the feature. So one of the first that comes into my mind is the path simulation proxy user interface. Now, what to imagine behind it? I mean, imagine that some of the users don't necessarily have an access to IP Fabric, and they are no network engineers, and the only thing they really need to know if certain source can reach certain destination, and they are only interested in knowing or understand result, right? So you as a user, before engaging and opening a ticket with the network team, you open a web proxy that is nothing else than some graphical user interface for users that will authenticate, and they will be able to place their source and destination with a very simplified result from IP Fabric. So the way it's going to work is that it's going to be a proxy interface. Once you put in a source and destination, it will contact IP Fabric over API, which is going to be happening on the backend. And on the front end, you as a user will only see results pass or fail, possibly with the pass simulation in SVG or PNG as a response. So imagine before, rather than engage with the network team directly asking for information, you just use the interface and use IP Fabric as a simulation engine for that. The second most common use case is the chatbot. Definitely one of the best way how to leverage IP Fabric API to use features like these, because plenty of times you or engineers not necessarily want to use or program any other platform in the form of the user interface, because they just can use the chat engines, right? So you can be either on Slack, Teams, or any other platform in your preference. And again, it's saving time. It's helping users that are not network engineers to understand the path before engaging the network team, and it can help the communication between teams greatly. Another use case is what I call the large-scale path analysis. So imagine you are implementing a new server and you want to make sure that 50 or even 100 source IP addresses are able to reach the server once all the security policies are implemented across your network or on a multiple of the firewalls that are on the path, and you want to run 100 simulations using IP Fabric, right? So in that case, you would not go to the user interface and put in the source and the destination 100 times, or try to think of, connected or co-joined subnets to run a simulation in the easier fashion, right? What you would do ultimately is to run end-to-end path simulation over API with a list of sources and list of destinations, and you can analyze whether or not the traffic will go the path you want. And the last, one of the most common use cases is that sometimes IP Fabric's API simulation capability is used to put in more information to the auto-generated tickets. So imagine a user will create a ticket, which is going to be the trouble ticket, complaining about a source and destination doesn't work. So instead of passing the ticket to the network engineering directly, first it will contact our API, get at least some usable information and the path analysis included into the ticket, and send it over. So now this is the end of the webinar. I hope you enjoyed it, and let's quickly go for a Q&A. Thank you.